All right, we got one more day off from work because of the California rainstorm. Again, we get about, I don't know, 3 inches of rain a year, but we got about 7 inches in the last week, so jobs need to dry out. I just wanted to talk about inverse or inversing. Out in the field, we inverse a lot because if we get calcs from the office, let's say we're going to stake a vault and they did the calcs for the vault in the office, and then we go out, we'll inverse between point numbers to just verify the dimensions of the vault size. It helps us stake it out. I inverse a lot when we're doing boundaries. Using We usually use GPS when we do our boundaries, and so just a quick example. And the reason why I'm making this video is because at times I try to explain to our new hires, or I'll say, hey, inverse me between point one and two. And they may not know what or why I'm doing it. Yes, they know how to push the buttons, but I'm just verifying what I have shot versus what our map says. A lot of times our maps may be from the 1970s, and we're not using 1970s technology. We're using 2024 technology, and just in my opinion, we're constantly checking our work because we're always called off. So always check your work. Always check back sites. Inverse. Make sure that where you're saying that or what you've located is what you've located. If it's something different, then you make notes on it. So I try to inverse all the time, just so when I leave the job site, I can prove where I was at or what I located. And where this comes up a lot is, let's say these are all intersections, and we have centerline intersection points out here in Southern California. Let's say the map calls out for a 1-inch iron pipe here, calls out for a spike and washer with this LS number here. Someone set a mag nail according to the map established by ties, and there's a well monument 3-inch brass disc. But I go out there, and maybe this pipe is correct, but I can't read the tag. Let's say it has a tag number, but I can't read the tag. So I write down 1-inch found 1-inch IP, nail and tag, illegible. Let's say there is a spike and washer. So this happened to me the other day for a basis bearing point. There was a spike and washer, and it shows a brass tag or a brass washer. I get there, and it's a spike and washer. It's a gear spike and washer, but it's a aluminum washer with a different LS number. But it's obviously that intersection point. Well, I have to prove that that is the point. I'm not going to pull ties on a 6-lane highway. So what I can do is I can inverse between those 2 points. I know that's the said point. This is my found point. My notes establish what I found. And I can do a quick inverse between point 1 and point 2 and make sure that my distance is close to what the recorded map says. And I do that all the way around. And it's just because that way it kind of checks my work. Let's say this point here is 10 feet off. I may call the office and I say, hey, can you look at your map and see if there's another center line, or maybe it's a BC or something like that. But while you're out in the field, you can do it. If you're using GPS, you're going to have different grid results compared to ground results, but you're going to be close. You're going to be close, and it makes it to where you can walk away from the job knowing that what you found is what you found. Then our new hires wonder, okay, what are these numbers that you're getting when it when you're inversing using a data collector? And I try to explain to them that, let's say you're going from point 1 to point 2. If you have a bearing that shows on the map, so it's, this is just a made up bearing. So you know that you're going to be increasing to the east, 600 some odd feet, and also increasing to the north. So this northing and easting, so you should have a higher northing, not by much because you're almost at 90, a little diagram there, but you're going to be increasing more. You're going to be increasing by your distance in your easting. And this is kind of an exaggerated way it looks like. So if this is your point 1, you're traveling along this bearing here, which means you would go, your northing would increase and your easting would increase. If you're starting from point 2 and going to point 1, this would then be a southwest bearing, which means you would go down in your northing and go down in your easting because you're heading southwest. I like to try to draw as many pictures as I can just to try to explain to people what's happening, but your northern and eastings have to do with north and east. There's not southerns and westerns, northings and eastings. And many times, in fact, I've really, I can't remember ever seeing it where bearings are shown as northwest or southwest. They're always northeast or southeast. And that just shows direction of that line, where it's going. So that's it. I'm not sure how many of you new guys are wondering what the hell are we looking at when we inverse. A lot of times now it's just checking calcs, it's checking shots so that we can move on to the next phase of the boundary. I like to check my work as much as possible, so when I leave the job site, I know what I've done and that it's done correct. As the saying goes, it's not wrong until they build it. So let's try to check our work before they build anything off it. That's it. Survey out.